Hello students and good morning. So now I am doing class for class 11 science. So today is the continuation class for the chapter trigonometrical ratios of compound angles. So in the last online class also we were doing the same chapter, that is trigonometrical ratios of compound angles. So in the last online class we did some formulae and we proved the first two formulae, that is proved geometrically that number one was we proved sine of a plus b is equal to sine a cos b plus cos a sine b, and the second one was cos of a plus b which is equal to cos a cos b minus sine a sine b. So I think you have understood it, so you have practiced it at home. So today also we will do the next two formulae, that is we will prove geometrically that. So third one is sine of a minus b is equal to sine a cos b minus cos a sine b. Here a is greater than b, and also we proved this formula number 4, that is cos of a minus b which is equal to cos a cos b plus sine a sine b. So if we prove this 1, 2, 3 and 4, and the other formula can be derived automatically from these four formulae. That is, number one was sine of a plus b is equal to sine a cos b plus cos a sine b. Cos of a plus b was cos a cos b minus sine a sine b. Third one is sine of a plus b which is equal to sine a cos b plus cos a sine b. And fourth one is cos of a minus b is equal to cos a cos b plus sine a sine b. So from these four formulae, the other formula can be easily derived. Like you can derive the formula for tan of a plus b, you can derive the formula for tan of a minus b, cot of a plus b, cot of a minus b, tan of a plus b plus c, and so on. Okay, so let's prove this geometrically now. So let us prove it now with the help of geometry, right? So let us prove it. Proof. So let us draw the figure. Let us draw the figure here also. Let OX be a revolving line, right? Suppose this is OX. Suppose OX is a revolving line. It revolves in anti-clockwise direction, that is in positive direction. This is anti-clockwise direction, means this direction, right? Suppose this OX revolving line revolves and traces out an angle XOY, right? So XO, and this is Y, and traces out an angle A. Is that clear? And then again it revolves. Now it revolves back. It does not revolve further, but it revolves back, right? And suppose it revolves back and traces out another angle B. That is, it should be straight, right? Suppose this is Z. Let OX be a revolving line. It revolves and traces out an angle XOY which is equal to A, and then again it revolves back, traces out another angle YOZ which is equal to angle YOZ is equal to B. Okay, so let us write here, let OX be a revolving line. Let OX be a revolving line. Let it revolve. Let it revolve and let it revolves and traces out an angle XOY is equal to A, and then again revolving back, and then again revolving back, revolving and then again revolving back, traces out another angle YOZ is equal to B. So what is angle XOZ now? What is the compound angle here? Angle XOZ is equal to A minus B. So this A minus B is a compound angle. Okay. So this angle will be A minus B, whole angle minus B. Okay. So here OZ is a final line, right? So let us take a point P in OZ, that is on final line OZ. You take any point P on it, okay? And from P you draw a perpendicular upon OX and OY respectively. This is PQ. PQ is drawn perpendicular upon OX and PR is drawn perpendicular upon OY. Is that clear? Next, again from R, you have to draw two perpendiculars. One on OX suppose this is RS, and you have to draw a perpendicular RT upon QP produced to T. QP produced to T. So again from R, you draw two perpendiculars RS and RT upon OX and QP produced to T. Is that clear? So now let us write here in OZ any point P is taken. In OZ any point P is taken. From P two perpendiculars from P, two perpendiculars PQ and PR are drawn upon OX and OY respectively. OX and OY respectively. Is that clear? Now again from R, two perpendiculars RS and RT are drawn upon OX and QP produced to the point T. So now again from R, comma, two perpendiculars RS and RT are drawn upon OX and QP produced to T. And QP produced to T. Okay. So again from R, comma, two perpendiculars RS and RT are drawn upon OX and QP produced to T. Is that clear? So now in this case, there is a right angle triangle PRT, right? So now here, this OX, this is your OX and this is your RT, they are parallel to each other. This OX and RT are parallel to each other and ORY cuts them. So these two angles are known as corresponding angle. It is just like this one. This is OX, right? This is your OX, okay? And this is your RT. This is your RT. These two straight lines are parallel to each other. And this straight line, that is ORY cuts them. So these two angles are known as corresponding angles, and these corresponding angles are always equal. Is that clear? So now if angle ROS is equal to A, this angle YRT is also A. Is that clear now? Because you know that if RT is parallel to OX and ORY cuts them, these two angles are known as corresponding angles, and these corresponding angles are always equal. These two angles are known as corresponding angles, and these corresponding angles are always equal. You know that, isn't it? So if this is angle A, this is also angle A. So now, since this is 90 degree, because PR is drawn perpendicular upon OY. PR is drawn perpendicular upon OY. Okay? So if angle YRT is A, this angle is what? This angle is 90 minus A. And this is also perpendicular, isn't it? RT is perpendicular to QP produced to the point T. So angle RTP is equal to 90 degree. So here angle PRT, you know that it is 90 minus A. So what is angle TPR? You have to find it again, right? So therefore angle, so let us write here angle So here angle ROS is equal to angle YRT. YRT is equal to A, because these are corresponding angles. These are known as corresponding angles. Okay. Now in right angled triangle, PRT, in right angle triangle PRT, we have angle PRT plus angle PTR plus angle RPT is equal to 180 degree. You know that PRT is a triangle, and the sum of the three angles of a triangle is equal to 180 degree. So here angle PRT plus angle PTR plus angle RPT is equal to 180 degree. So from this relation we can get the value for RPT, angle RPT. Okay, what is angle PRT? What is angle PRT? It is 90 degree minus A. This is 90 degree minus A plus, what is angle PTR? It is 90 degree plus angle RPT, which is equal to 180 degree. Okay, so 90 plus 90 is here 180 minus A plus angle RPT is equal to, this is 180 degree. Okay, so from both the sides you can cancel this 180 degree. So what is angle RPT now? So angle RPT is equal to A. So which is equal to, what is angle RPT? What is this angle? This is also A. So this angle is A. So I think you have understood it. Okay. Now from this figure now we will prove this two formulae. That is, sine of A minus B is equal to sine A cos B minus cos A sine B. Here A is greater than B, and also you can prove cos of A minus B is equal to cos A cos B plus sine A sine B. Okay, so you can copy it. You have to draw the figure also. Okay. So now I will rub it, so you can copy it. Now with the help of this figure, we can prove this formula number 3 and formula number 4. So now let us prove it. Now let us write down the compound angle A minus B. Where is compound angle A minus B here? It is angle POQ. Let us consider this right angle triangle POQ in order to prove this formula number 3 and formula number 4. In right angled triangle POQ. So let us first prove sine of A minus B. So sine of A minus B is equal to, some people have, this is perpendicular upon hypotenuse, okay? So, or this is sine of A minus B is equal to, so which is the perpendicular, which is the hypotenuse here? So now we are considering this right angle triangle POQ, okay? So here this angle A minus B is considered. If this angle A minus B is considered, the side opposite to this angle considered will be the perpendicular always. So PQ is the perpendicular, OQ is the base, and OP is the hypotenuse. Okay. So what is perpendicular here? It is, this is PQ divided by what is hypotenuse? It is OP from the figure, right? So, or this is sine of A minus B is equal to, now from the figure, how will you write PQ? So from the figure, this PQ can be written as TQ minus PT, isn't it? So PQ can be written as TQ then minus TP whole divided by OP. Is that clear now? So now in the next step, or sine of A minus B is equal to, again, what is TQ here? This TQ is equal to RS, isn't it? So from the figure, it is clear that TQ is equal to RS. So here you can write, instead of TQ, write RS minus TP divided by OP. Is that clear to all of you? So I think you have understood it. So let us separate the fraction now. Therefore, sine of A minus B is equal, let us separate the term RS upon OP minus TP upon OP. Minus TP upon OP. Is that clear? So again, now sine of A minus B is equal to, now RS upon OP is there. There are two straight lines, RS and OP. Which straight line is intersecting both RS and OP such that a right angle triangle may be formed, so that you can write down the formula. Okay. So this is RS and OP. RS is this one, this is your RS, right? And which is OP? This is OP. This RS and OP is intersecting OR, isn't it? This RS and OP are intersecting this OR. That is, OR is the common line of intersection for both RS as well as OP, such that here ROS or right angle triangle is formed, and here ROP or right angle triangle is formed. Okay, so here you can write RS divided by this RS and OP is intersecting OR. Okay, so this is OR into OR upon OP. Let us multiply and divide it by the common line of intersection, that is OR. Similarly, minus TP and OP. This is your TP and this is your OP. This is your TP and OP, okay? This is TP and this is your OP. So both this straight line are intersecting PR, isn't it? so that PRT is a right angle triangle and RPO is a right angle triangle. Okay, so both these straight lines TP and OP are intersecting the straight line PR. So PR is the common line of intersection. So it is TP divided by PR. So it is multiplied and divided by PR. So it is PR upon OP. So or now this is sine of A minus B is equal to, now looking at the figure, you tell me what is RS upon OR. This is RS divided by OR. That is, now here angle A is considered. If angle A is considered, the side opposite to the angle A will be the perpendicular. This is perpendicular, this is base, and this is hypotenuse. Clear? So RS upon OR means P upon H. That is your sine A. Let us write here, this is sine A into. Now OR upon OP. This is OR upon OP. So POR is a right angle triangle. So in this case, this angle B is considered. The side opposite to the angle B will be the perpendicular. This PR will be the perpendicular. OP is the hypotenuse and OR is the base. Okay. So what is OR upon OP? This OR upon OP is base upon hypotenuse, which is cos B. Here the angle is B here. So it is cos B minus, next, TP upon PR. TP upon PR. Now angle A is considered. TP upon PR. This is TP upon PR. Angle A is considered. The side opposite to the angle A, that is TR, will be the perpendicular. TP will be the base and PR will be the hypotenuse. So what is TP upon PR? It is base upon hypotenuse, which is cos A. Right? So here you can write cos A. This is your cos A into, what is PR upon OP? Now this is PR upon OP. Now POR is a right angle triangle. Here angle B is considered. The side opposite to the angle B will be the perpendicular. This PR is perpendicular, OP is the hypotenuse, OR is the base. So what is PR upon OP? What is PR upon OP? That is PR upon OP is P upon H, perpendicular upon hypotenuse, which is sine B. So here you can write PR upon OP is sine B. So we have proved the required result. Okay. So what is sine of A minus B? It is sine A cos B minus cos A sine B. So it is proved. So I think you have understood it. Okay. Now we can copy it. Again, from the same figure, we can prove number 4, formula number 4. That is cos of A minus B. So we can copy it. Now again from the same figure, we will prove formula number 4. That is cos of A minus B is equal to cos A cos B plus sin A sin B. Now again you have to consider the same right angle triangle, that is POQ, that is angle A minus B is considered. In right angled triangle POQ. In right angle triangle POQ. Now cos of A minus B. Therefore, it is cos of A minus B. You know that curly brown here. It is base upon hypotenuse. Therefore, cos of A minus B is equal to, what is the base here? So since this right angle triangle POQ is considered, and again this angle A minus B is considered, the side opposite to the angle A minus B will be the perpendicular. This PQ will be the perpendicular. This PQ is perpendicular, OQ is the base, and OP is the hypotenuse. Okay? So what is the base in this case? OQ. So let us write here OQ divided by, which is the hypotenuse? OP is the hypotenuse. Is that clear from the figure? I think I've understood it. Or now this is cos of A minus B is equal to. Now looking at the figure, how can you write this OQ? This OQ can be written as OS plus SQ, isn't it? So let us write here OS plus SQ divided by, this is OP, right? So in the next step, again you can simplify it further. Cos of A minus B is equal to OS, keep it as it is, plus. So in the figure, what will you write for SQ? This is your SQ. So this SQ is equal to RT, isn't it? From the figure, we can write down that SQ is equal to RT. So here you can write RT divided by OP. This is RT divided by OP. So I think you have understood it. So you can separate this fraction now. Therefore, cos of A minus B. So cos of A minus B is equal to, let us separate the term. It is OS upon OP plus RT upon OP. RT upon OP. Therefore, cos of A minus B is equal to, now what will you do in the next step? Now you have to check which straight line is intersecting both OS and OP. Which straight line is intersecting OS and OP? OS is this one, OP is this one. So OR, isn't it? So that a right angle triangle will be formed there. So this OS and OP both are intersecting straight line OR, right? So here POR is a right angle triangle and this OP, POQ is a right angle triangle. Okay. So now ROS, sorry, in this case OS and OP. This OS and OP both are intersecting straight line OR. So in this case ROS is a right angle triangle and also POR is a right angle triangle. So that you can easily write down the formula. So OS and OP both are intersecting straight line OR. So let us write here OS upon OR into OR upon OP plus. Similarly, which straight line is intersecting both RT and OP? Now it is RT upon OP. Which straight line is intersecting both RT and OP so that a right angle triangle may be formed there? So RT and OP. This is RT, right? And this is OP. RT and OP both are intersecting straight line PR such that PRT is a right angle triangle and RPO is a right angle triangle. That is, both these RT and OP are intersecting PR. So here we can write multiply and divide by PR. So it is RT upon PR into PR upon OP. Is that clear? So next, or now we can write down the formula cos of A minus B. Now what is OS upon OR? So let us check it in the figure. What is OS upon OR? OS upon OR. OS upon OR. ROS is a right angle triangle. So here angle A is considered. The side opposite to the angle A will be the perpendicular. This RS is the perpendicular. OS is the base. OR is the hypotenuse. So this is base upon hypotenuse. So base upon hypotenuse is cos A. Okay. So you can write here cos A into, what is OR upon OP? This is OR upon OP. So POR is a right angle triangle, that is considered. So here angle B is considered. The side opposite to the angle B, that is PR, will be the perpendicular. OP will be the hypotenuse. OR will be the base. So this is also OR upon OP. OR upon OP, isn't it? So OR upon OP means base upon hypotenuse, which is cos B. So which is cos B plus. So what is RT upon PR? Now RT upon PR is there. This is RT upon PR. So TRP is a right angle triangle that is considered. So here also angle A is considered. The side opposite to this angle A will be the perpendicular. That is TR will be the perpendicular, or RT will be the perpendicular, PR will be the hypotenuse. So what is RT upon PR? P upon H, that is sine A. P upon H, sine A. So it is sine A into. What is PR upon OP? So this is your PR upon OP. So POR is a right angle triangle. Here angle B is considered. The side opposite to the angle B will be the perpendicular. This PR will be the perpendicular, OP is the hypotenuse, and OR is the base. So it is PR upon OP. PR upon OP means P upon H. P upon H means sine B. So PR upon OP is sine B. So we have proved it. That is cos of A minus B is equal to, it is cos A cos B plus sine A sine B. So we have proved it. So I think you have understood it. So you can again revise it at home. Okay, try to understand it. If you don't understand it, you can call me or you can comment me. You can write down the comment in the comment box. Okay, so now let's prove another formula with the help of this first four formulae. Like from in one we did sine of A plus B, formula for sine of A plus B we did in formula number 1. In formula number 2 there is cos of A plus B. The first one is sine of A plus B, second one is cos of A plus B, third one is this sine of A minus B, and fourth one is cos of A minus B. And from these four formulae we can derive other formula. Okay, so let us do it now. So you can copy it. So now we will derive some formula from this first formula that we just proved it. Okay, so now formula number 5 was, what was the formula? Tan of A plus B is equal to, this is tan A plus tan B divided by 1 minus tan A tan B. And number 6th was tan of A minus B is equal to tan A minus tan B divided by 1 plus tan A tan B. So let us prove this formula with the help of 1, 2, 3 and 4. So formula number 5 is tan of A plus B is equal to tan A plus tan B divided by 1 minus tan A tan B. And formula number 6 is tan of A minus B is equal to tan A minus tan B whole divided by 1 plus tan A tan B. Okay. So let us prove number 5 now. So formula number 6 is your homework. You can prove formula number 6. I'll show you number 5. So similarly you can prove formula number 6. Okay. So proof of 5. So let us do proof of 5 now. Okay. So now here, what is LHS? Here LHS is tan of A plus B. So how can you prove that tan of A plus B is this one? Tan A plus tan B upon 1 minus tan A tan B with the help of first 4 formulae. Okay. So tan of A plus B can be written as sine by cos, isn't it? It is sine of A plus B divided by, this is cos of A plus B. Is that clear? So which is equal to, what is the formula in the numerator? What is sine of A plus B? We just proved it, isn't it? What is sine of A plus B? It is sine A cos B plus cos A sine B. This whole divided by, what is the formula for cos of A plus B? It is cos A cos B minus this is sin A sin B. So I think you have understood it. Okay, so we can write down this formula. Okay, so now you have to convert it into tan A plus tan B divided by 1 minus tan A tan B. This should be 1. Instead of this cos A cos B, there is 1. That means it should be divided by cos A cos B. If it is divided by cos A cos B, this sin A sin B should also divided by cos A cos B. If denominator is divided by cos A cos B, the numerator should also be divided by cos A cos B. And after separating, we can prove this formula. Okay. So here let us write dividing both the numerator and the denominator by which term? Cos A cos B. Okay, by cos A cos B. Okay, so which is equal to, now we can divide both numerator and the denominator by cos A cos B, and you can separate the term. That is, in the numerator you can write this is your sin A cos B divided by cos A cos B, then plus sign is here, cos A sin B divided by, this is also divided by cos A cos B. So this whole divided by, in the denominator also you have to divide it by cos A cos B. You can separate the term. That is, this cos A cos B is divided by cos A cos B. Cos A cos B is divided by cos A cos B, then minus sign. Now also this sin A sin B is divided by cos A cos B. That is, sin A sin B is divided by cos A cos B. Is that understood now? So you can cancel here this cos B, this is cos A can be cancelled, this cos A, this cos B can be cancelled. So which is equal to, now this cos B is cancelled. What is sin A by cos A? This is your tan A plus, what is sin B by cos B? This is tan B divided by, this is your 1 by 1 is 1 minus, what is sin A by cos A? This is tan A, and what is sin B by cos B? This is your tan B. So we have proved it. So is that clear to all of you? So I think you have understood it. So you can copy it. So you can prove this formula number 6. So that is your homework. Okay. So you can copy it. So now let us prove this formula number 7 and 8. So let us prove this number 8 here. So this 7 is your homework. Okay. So let us prove this formula number 8. So this 7 is your homework. Right. So let us prove this 8. Proof of 8. Proof of 8. Okay. So here LHS is equal to, this is cot of A minus B. So here also you have to use formula number 1, 2, 3 and 4. That is, it may be sin of A plus B, cos of A plus B, sin of A minus B, cos of A minus B. Okay. So what is cot of A minus B? This will be cos of A minus B divided by, this is sin of A minus B. Right. So now let us use the formula. Now you should know this formula, cos of A minus B and sin of A minus B. What is cos of A minus B? It is cos A cos B plus sin A sin B. Right. It is cos A cos B plus sin A sin B. And what's about this sin of A minus B? it is sin A cos B minus cos A sin B. So I think you have understood it. Okay, so now we have to prove this formula, cot A cot B plus 1 divided by cot B minus cot A. So this term sin A sin B should be 1 here, isn't it? So to make it 1, sin A sin B, to make it 1, it should be divided by sin A sin B. So if this sin A sin B is divided by sin A sin B, this cos A cos B should also divided by sin A sin B. If the numerator is divided by sin A sin B, this denominator should also be divided by sin A sin B. So let us write here, dividing both numerator and denominator, by what? Sin A sin B, by sin A sin B. Is that clear now? So which is equal to, now in the numerator we can write, this is cos A cos B should be divided by sin A sin B. Okay, then plus sign. Again this sin A sin B should be divided by sin A sin B again. So this is sin A sin B divided by sin A sin B, this whole divided by. Now in the denominator also you should divide it by sin A sin B. So it is sin A cos B divided by sin A sin B. Then comes minus sign, cos A sin B, cos A sin B divided by sin A sin B. So is that clear? So I think you have understood it. So we can cancel the similar terms here, sin A by sin A, sin B by sin B will be cancelled. So here sin A will be cancelled, and here sin B will be cancelled. So which is equal to, what is cos A by sin A? It is cot A into cot B minus 1 by 1 is 1 divided by. So what is this cos B by sin B? It is cot B minus this one is cot A. So it is proved. So I think you have understood it. So you can copy it. So this you can prove formula number 7. Do it at home. Okay. So you can copy it. Now we will prove another formula. So now let's prove this formula. That is formula number 9. That is, you have to prove tan of A plus B plus C is equal to tan A plus tan B plus tan C minus tan A tan B tan C whole divided by 1 minus tan A tan B minus tan B tan C minus tan C tan A. So let us prove it. So let us write down here, LHS is equal to tan of A plus B plus C. So now in this case you can use the formula of tan of A plus B. So let us take this A plus B as A plus B as A, and C as B, so that we can use the formula of tan of A plus B, isn't it? Here A plus B is taken as A and this C is taken as B. So what is the formula? Formula is tan A. What is tan A? Tan of A plus B plus tan C, that is your tan A plus tan B divided by 1 minus tan A tan B. 1 minus tan, what is A? It is A plus B, and what is tan B? It is tan C. So I think you have understood it. So now again you can use the formula of tan of A plus B. You know tan of A plus B now. This is tan A plus tan B divided by 1 minus tan A tan B. Okay, then you can write here plus tan C. Similar in the denominator, 1 minus, what is tan of A plus B again? It is tan A plus tan B divided by 1 minus tan A tan B. So here bracket is closed. This is the formula of tan A plus B. Then outside bracket you can write tan C. Is that clear? So let's take the LCM in both numerator and the denominator. So in the numerator, what's the LCM? It is 1 minus tan A tan B. Let us take the LCM as 1 minus tan A tan B. You know how to simplify it, isn't it? So 1 minus tan A tan B is the LCM in the numerator. So it is tan A plus tan B. Tan A plus tan B. Right? Tan A plus tan B plus tan C into 1. Plus tan C. Then plus into minus. Minus. Tan C is multiplied by tan A tan B. So it is minus tan A tan B tan C. Minus tan A tan B, and this is tan C. So this is the numerator. Similarly, in the denominator, what's the LCM? What's the LCM in the denominator? 1 minus tan A tan B. So what will be there up in the denominator? So here 1 minus tan A tan B into 1. That is your 1 minus tan A tan B. Is that clear? So we can multiply by minus tan A into tan C. This is your minus tan A tan C. Minus tan A tan C, right? Then minus into plus is minus tan B tan C. So it is minus tan B tan C. So I think you have understood it. Okay, we have just simplified. So take the LCM and simplify in both the numerator as well as in the denominator. So you can cancel this LCM. You can cancel it. So which is equal to now? What is there in the numerator? It is tan A plus tan B plus tan C minus what is here? Tan A tan B tan C minus tan A tan B tan C. So this whole divided by, in the denominator, it is 1 minus tan A tan B minus tan A tan C minus it is tan B tan C. So it is proved. So in the denominator you may write here 1 minus tan A tan B minus tan B tan C, then minus tan C tan A. You may write it. Same expression is there. So is it proved now? So it is done. Okay. So you can copy it. So we have proved this formula also, but you have to remember all these formulae, right? So that it will be easier for you to do the problem. So if you remember the formula, if you can apply the formula, then you can easily do the problems. Okay. So let us prove the last two one, that is 10th and 11. Okay. So you can copy it. So let us prove formula number 10 and formula number 11. Okay. So let us write here formula number 10 and formula number 11. Okay. So could you remember that formula number 10 and 11? So let us write down the formula first, then we will prove it. Okay. So formula number 10 was, the formula was sine of A plus B into sine of A minus B is equal to, what was the formula? It was sine square A minus sine square B is equal to cos square B minus cos square A. Okay. So number 10. And what was formula number 11? It was cos of A plus B into cos of A minus B is equal to, what was the formula? Could you remember the formula? What is cos of A plus B into cos of A minus B? It is cos square A minus sine square b, or it may be cos square b minus this is sine square a. So I will do proof of 11. So number 10 will be a homework. Okay. So number 10 you can do it at home. Let's do it here. That is formula number 11. But you have to remember both the formula 10, 11. Okay. So let us prove this formula number 11. So LHS is equal to, this is cos of a plus b into cos of a minus b. So let us prove the formula now. Which is equal to, first you prove cos square a minus sine square b. So what is the formula for cos of a plus b? Let us write it. What is the formula? Cos a cos b minus sine a sine b, right? Is that clear? It is cos a cos b minus sine a sine b. That is the formula for cos of a plus b. What is the formula for cos of a minus b? It is cos a cos b. If it is minus sign, you should write a plus. It is sine a sine b. Is that clear to all of you? So now again, which formula is used from algebra? A minus b into a plus b. What is a minus b into a plus b? A square minus b square. So what is a whole square here? It is cos a cos b whole square minus this is sine a sine b whole square. So I think you have understood it. Okay. So which is equal to, this is cos square a cos square b minus this is your sine square a into sine square b. But what is to be proved here? We have to prove only cos square a minus sine square b. We need only cos square a and sine square b. But we don't need cos square b and sine square a. Let us convert this cos square b into sine square b, and let us convert this sine square a into cos square a. Okay. So which is equal to, this is cos square a within bracket. What is cos square b? It is 1 minus sine square b. Okay. Then minus, what is sine square a? Let us convert into cos. 1 minus cos square a into this is your sine square b. So in this case, cos square a and sine square b are kept as it is. Okay. Cos square a and sine square b are kept as it is. Only you have to convert cos square b in terms of 1 minus sine square b and sine square a in terms of 1 minus cos square a, so that we can easily prove this cos square a minus sine square b, right? So which is equal to, this is your cos square a minus, let us multiply it. It is cos square a sine square b, and this is minus sine square b minus sine square b, minus into minus, plus this is your cos square a into sine square b. So I think you have understood it. Okay. So here you can cancel these minus cos square a sine square b plus cos square a sine square b. Both are same, but they are of opposite sign. You can cancel it. So which is equal to, this is your cos square a minus sine square b. So we have proved it. So first part is done. That is cos square a minus sine square b is proved. Again, this is equal to cos square b minus sine square a. You have to prove it. Okay. So which is equal to, now again this cos square a, you can write it in terms of sine square. That is your 1 minus sine square a. This is the formula, you know, from class 10, isn't it? Then minus sine within bracket. So let us convert this sine square b in terms of cos square b. So it is 1 minus cos square b. It is 1 minus cos square b. Since there is minus sign here, so you have to put it within bracket. Okay, so that the sign can be changed, so that we can prove cos square b minus sine square a. So which is equal to, this is 1 minus sine square a minus 1 minus into minus plus this is your cos square b. So here you can cancel this, plus 1 minus 1 will be cancelled. So which is equal to, let us write cos square b first. Cos square b minus sin square a. So it is done. So it is also proved, isn't it? Cos square b minus sin square a. This is cos square a minus sin square b. So it is proved. So I think you have understood this proof. Proof number 11. So you can easily prove this formula number 10. Similarly, as we have done in formula number 11, you can prove formula number 10. So we have proved almost all the formula. Okay, so there is also homework. You can do it at home. Okay, I think you can prove those I have given you for homework. So I think you can do it. Okay, अनि त्यहाँदेखि तिमीले के गर्नुपर्छ, you have to remember, you have to memorize all this formula, so that in the next class we will do problems from the book, so that it will be easier for you if you remember the formula. Okay, so you have to apply all this formula in the next class. Okay, so in the next online class we will do problems from the book. Okay, so we will use all this formula. That is, all this formula, that is 11 formula are there. So you have to use all this formula in order to prove the problems that is given in the book. So this much is for today.